In this video, we're going to review the classification of matter in detail. So remember that matter is anything that has a mass and occupies space or has a volume. And so all of the matter that exists can be classified into the method that you see over here. So here we have matter. Matter can exist as a pure substance or as a mixture. If matter is a pure substance, then it can be an element or compound. And if matter is a mixture, then it can be a heterogeneous mixture or a homogeneous mixture. So we're going to go through each of these aspects of this diagram to make sure we understand what all the components mean. So we'll start off with pure substances. Like I said, if you're pure substances, you could either be an element or a compound. So the element, that's that smallest Lego piece. Is the pure substance is made up of only one type of atom. And the way you would recognize that if it was written down is you simply have only one uppercase or capital letter in the symbol. Whereas compounds, they are still pure substances, but they're made up of two or more different elements chemically combined. So they have to be chemically combined together. And you would know that if I gave you a formula because you'd have two uppercase letters or more. So NaCl is a compound. NaCl. And students often get confused. They say, well, how is that pure? There's two elements in there. It's true, but they are two elements that are chemically combined together. So it's almost as if they are now one. This H2O is now one. This is now one because they're chemically attached together. It's not like a salad where the lettuce and the carrots and the cucumbers are still separate. These are now one pure compound, one pure compound, one pure compound. So pure substances can be elements or compounds. So we can practice here. So let's identify the following as elements or compounds. They're all pure substances because they're just elements or compounds. Here we have Ca, one uppercase letter. That's an element. Here we have CaCl2, that's a compound, and you remember it's a metal and non-metal, so it's ionic. Here we have H2O, there's two elements in there, two uppercase letters that are chemically combined, two non-metals actually, so it's a compound, and you might remember it as a molecular or covalent compound. Na, simply an element. O2, students get confused here. They see O2 and they say, oh, it's two elements together. True, but it's not a compound because a compound has to be two or more different elements connected together. So this here is still an element, but we would call it a molecular element. It's an element because it's two of the same elements connected together, but it still counts as an element, not a compound. Cl2, that's right, molecular element. And then NaCl, another compound there, ionic, metal, and non-metal. So matter can be pure substance or a mixture. If it's pure substance, it can be an element or a compound. Element is that smallest building block. It's only made up of one type of atom. Compound is made up of two or more different elements chemically combined together. And in the formula, you'll usually see two or more capital letters or uppercase letters. So visually, what does that look like? So here, for example, we have, let's say this is a little container. And these little circles here are an atom, let's say an atom of copper. So you can see this container is a pure substance because it only has copper atoms in there and nothing else. Here we have another container, a molecular, another container over here. But rather than the individual circles being separate, we have these little groups of circles here, like this, like this, like this, like this. Now, first of all, what I want you to notice is that those groups are all identical. So this is a pure substance in here. It's purely these identical groups of circles here. Let's say each one of those circles is an H. This would make this H2. So this, for example, would be H2, H2, just pure H2, molecular element as a pure substance. So that's visually what it would look like. So if you have just hydrogen gas in a flask with nothing else in there, like if there's no O2, no other mixture, if you somehow manage to only get H2 in a flask, that would be considered a pure substance pure substance. If you have a copper wire and it's only copper, like this, it's a pure substance. So again, this is not a compound because it's two of the same elements connected to each other. This is actually called a diatomic element. So when you have two of the same elements connected together, yes, it's a molecular element, but when it's specifically two, we call it diatomic element. So Cl2 is diatomic, F2 is diatomic, O2 is diatomic, N2 is diatomic, Br2 is diatomic. You might have remembered your Hofbrinkel elements. Hofbrinkel. These are the ones that are found in nature with twos at the bottom. So they're examples of molecular elements, but they're specifically diatomic because they're found combined with another one of themselves in nature. Here we have an example of a pure substance that's a compound. So if we're looking at this box here, we have this molecule. Now we know it's a compound because you have different color circles there. So you have the very dark one in the middle and the gray ones on the side. So there's two different elements in there. If this is O and this is H, they're chemically combined. This is simply H2O. So here we have the same compound in the box, H2O, H2O. So this will be considered a pure substance. That's a compound. And they are chemically combined. So it's as if they are one. Even though there's different elements there, they're not separate. This is not, for example, for them to be separate, you would have to have this. So for example, this would have been H2, and then maybe you had this one here, which is O2. Now this is no longer pure. It's a mixture of H2 and O2 in the same box. That would no longer be pure. This here's in the box, you only have H2O. So we can go ahead and figure out if these pure substances are elements or compounds. So here you can see, for example, you only have one color circle everywhere. So we know this is an element, and you can pause the video and try it out yourself. Here you have a dark circle and a lighter circle. We know it's a pure substance because it's always the same sort of dark and lighter circle every time. But since they're different circles connected to each other, we know it's a compound. So this might be something like NaCl, for example. Let's look at this one here. So we clearly have, well, we know it's a pure substance because it's all the same compound. And I just kind of gave it away. It is a compound because you have different elements chemically combined. So this is a compound. And finally, we get over here. Notice these circles are chemically combined, but they're the same circle, same color. So this is still considered an element. But it would be a molecular element. So for example, it might be, let's put Me, molecular element. And this here is just an element. We sometimes call this atomic element if it's by itself. And over here we have molecular element. So for example, this could be O2. For example, this could be Cu. This could be NaCl. So that was the pure substance side. Now we're going to take a look at the mixture side. So a mixture is something that has more than one type of particle within it. So if you look at this box here, this has more than one type of particle. We have some, I don't know, let's just say that's this Cu. This over here is some NaCl. And this over here is some H2O. We have some copper, some water, and salt all mixed together within that box. So we have a mixture over here. Now, visually, when you're looking at mixtures, because when you're looking at mixtures, when you're looking at substances, you cannot see the atoms, you cannot see the compounds with the naked eye. So visually, when you're looking at something that you can see, we can classify mixtures as being either heterogeneous or homogeneous, and we're going to take a look at visually what that would look like to the practical aspects of what you can see in just a moment. First, we're going to try to complete this table together. So you can pause the video and try it out yourself and see if you're on the right track, and then compare with me as you do that. So we're going to classify these substances as mixtures of pure substances, and if they're pure substances, we're then going to classify them as elements or compounds. So let's start over here. Here, it looks like we have different substances within the one box. They're not all the same, so we know this is going to be a mixture. And specifically, it looks like a mixture of compounds. there's different compounds there. This is a compound, this is a compound. So mixture of different compounds. So it's not a pure substance. This one over here looks like it's all the same. So this is definitely a pure substance, PS, pure substance. And this is a compound, so it's a pure substance compound. I know that because it's two different circles kind of combined. Here we have the same circle over and over and over again. It's only one circle every time, so we know it's a pure substance. It's only one circle every time, so we know it's an element. Now here we have a compound, and here we have a bunch of the same circles connected to each other. Now, these are not the same. These here are not all the same as each other. We have this and this. They're different. So we know we have a mixture. So we know it's not a pure substance. And this looks like a mixture of a compound, and this is probably a molecular element of some sort. So mixture of compound and element. So visually, what would this look like for mixtures? So you can have homogeneous mixtures, which we call solutions as well, or you can have heterogeneous mixtures. So homogeneous mixture or homogeneous mixture, the prefix means the part of the word that's in the front. Homo means the same. So you have different particles in the mixture, but they look like they're one. They're indistinguishable from each other. You can't tell them apart. It looks like a uniform composition. So if you take a look at this example over here, this giraffe statue here is made of brass. It's a whole bunch of metals combined together. They're not chemically combined, though. They're still separated. They're dissolved into each other. But you can't see all the different metals. It looks like it's just a uniform composition. Or if you make Kool-Aid, so let's assume this ice wasn't in there. The Kool-Aid looks like a uniform composition. Or if you take just salt and water, some H2O and some NaCl, you can't tell that there's salt in the water. It looks like a nice uniform composition. So that's a homogeneous mixture or a solution of salt and water. So we'll tell, so rather than say a homogeneous mixture of salt and water, we'll say this is a solution of salt water. So again, we use the word solution oftentimes for homogeneous mixtures. So here we could have some salt, we put it in the water and we stir, we dissolve it, and it looks like one composition, like there's only one type of particle there, even though we know there's more than one. If we were to zoom in and make a box for this, so let's make a box to see what this would look like. So you might have, for example, this would be the NaCl, and then you'll have the H2O. So this would be considered a mixture of compounds. Now you wouldn't be able to see this, but if I tell you you have a salt water solution, you know it's a mixture because it's not just water, it's not just salt, it's a mixture of those compounds. So in a sense, it's a mixture of pure substances, so you can't call it a pure substance if it's a mixture. Here's another example of a homogeneous mixture that we call an alloy. An alloy is really just a solution of solids. When we mix metals together, we don't chemically combine the metals. We just sort of dissolve them into one another. We always think that to dissolve something, you have to have a liquid and a solid, but that's not always the case. You can dissolve solids into solids as well. So the money coins that you have, they're examples of alloys, or a bronze metal is an alloy of copper, iron, and some other solid elements that are mixed together. And so here you can see various different compositions of alloys. You don't have to memorize these, are just examples. Jewelry that you wear, when you buy gold, you don't get pure gold. It's typically an alloy. You can even get some gold that has different colors in it. So for example, you can get rose gold. Rose gold has a tint of red from more copper being added to it. You can get green gold. So you can modify the characteristics of the gold or the jewelry you buy by essentially dissolving other metals into it. And typically you do that so that you can make the gold harder, so that it maintains its shape. But this is just one example of a homogeneous mixture, an alloy, which is a solution of solids. So we give it a special name. And then we go to heterogeneous mixtures. There, visually, you can see the different components. So if you look at this chocolate chip ice cream here, you can see the chocolate chips, you can see the ice cream. If you look at this little snack here, you can see all the different components like this. If we look at this sand being added to water, you can see the water and you can see the sand still separated. In this chocolate chip cookie, you can see the chocolate chips and you can see the dough. So you can see all the different components. And we also sometimes call this a mechanical mixture. And hetero meaning different. So the prefix hetero means different, and so you can see all those different components, which is why we call it a heterogeneous mixture. One specific example of a heterogeneous mixture is something called a suspension, when you have large particles that settle out into layers. So, for example, if I have, let's say, sand and water, there's large particles in the sand and water. Eventually, when you let it settle, it'll form a layer at the bottom over here of the water. Or oil and water, you can see you have suspensions of droplets here, but eventually it forms a layer. They don't dissolve into each other. So the oil goes on top and the water goes at the bottom because the water is more dense than the oil. So this is a summary of the classification of matter. Matter can be pure substances. It can be a mixture. If it's a pure substance, it's made up of one type of particle. That one type of particle can be an element or it can be a compound. The compound can be ionic if it's a metal and nonmetal, or molecular if it's two or more different nonmetals. The element can be a molecular element if it's just two of the same nonmetal connected to each other, like H2, O2, I2, etc. Or it could be an atomic element, which just means just one straight up atom of that element. So Na or Cu or Pb, various examples like that. And so here you can see some examples. We have this would be like H2, for example. This is H2. This could be Cu. Over here are compounds. This could be H2O. And then, like I said, you could have mixtures. Mixtures is where you have more than one type of particle. And visually, when you're looking at them, they could be heterogeneous mixtures or homogeneous mixtures. Heterogeneous mixtures, you can call them mechanical mixtures, and one specific type is a suspension, as we saw with the oil droplets in the water. And then homogeneous mixtures, we typically call them solutions, like when you dissolve salt in water. And you also, another specific example is called an alloy, which is when you dissolve solids into each other. So it's a solution of solids. And you should be able to complete a table like this. Classify substances based on pure substances or mixtures. I'll do one example with you, and then you can do or two examples with you, and then you can do the rest yourself. So let's go ahead and try air. Air, if you look at it, you can't really see the different parts of air. So I will let you know that it is a mixture. It's a mixture of different gases, but you can't see the different parts. So we know it's nothing here. It's not a pure substance. It's a mixture of pure substances. Now, since you can't see the different parts and it looks uniform, we would say that that's a homogeneous mixture. Let's take a look at salt. We put in brackets there NaCl. Salt is a compound, which means it's a pure substance. Salt dissolved in water. So we have NaCl and water, H2O. They're compounds, that we have a mixture of compounds here. We have some salt in the glass of water. So it's not a pure compound by itself. It's a mixture of compounds. Now, we have to think about this. If you had salt water and it was nice and dissolved, you couldn't tell the different parts apart from each other, we would say that that would be a homogeneous mixture. So you should be able to go through these and figure out where the different substances would be classified. If you're not sure what they would look like, you can just go on Google Images and just Google, for example, brass elephant statue or chocolate chip cookie if you don't quite know what things look like, or salad, for example. So just make sure you do that. And if you're having some trouble, make sure you go back and take a look at the examples from the previous slides.